Cool. So with that, we'll start the recording. Okay, guys. So today we are going to discuss the starters 86 from Codechef. So I'll be discussing the first three questions. That is the string game, largest y, and minimum operations. So let's get started with the very first question. So the question states, or the problem states that Zlatan and Ramos, I don't know why they give so complicated names, but are playing a game on a binary string s of length n. So Latin and Ramos take alternating moves. So let's just call them A and B. So A goes first, and what they do is that from the string, they have to pick two characters which are adjacent, right? So they'll pick the characters at I and I plus one, and they should not be similar. So in case if they're not similar, then they can like pop it out. So Latin would say okay, or the player A would say that I'm going first. So he'll say that okay, cool. So if you're going first, in that case, just look at the string, pick any two characters which are adjacent and not similar. So since it's a binary string, there are only two possibilities for every character. That is a 0 and a 1. So for example, this is a string. Over here, he can say, okay, I'm going to pick these two characters or these two characters because they are adjacent and are not equal. After the player A performs this operation, the remaining string, so these two characters which he selected would be popped out of the string or would be deleted from the string. The remaining string would be then given to the other player, that is the player B, and he would also try to perform the similar operation at the end. Whosoever has his string remaining would actually win. So a pretty basic question. Yeah, this is the wrong implementation, but okay, give me a second. Yeah, so this is the code for it. So what we had to do is that we had to pick up two characters. So whenever two different characters are adjacent, we can actually pop them. So that's what we are doing over here. So I'll keep a track of the characters I'm adding using a stack. You can actually use a string over here. So you can say string res, and over here you can say res.size and res.back. So the thing actually remains same, whatever you want to do, but whenever we are trying to push and pop, then most of the time stack is the way to go, or the first thing that comes to our mind is stack. Hence I used a stack, but it's not like you have to, you have to be concrete with the stack or you have to fixate with it. You can use whatever data structure you like. So this would work with this string as well. So what we're doing is we are checking that if the current character and the previous character which was just passed. Okay, give me a second. Okay, over here. Okay, so we're just checking if the current character and the previous character, they're different. In that case, you can pop the previous character and you cannot, you'll say that, okay, I'm not going to add the current character also. That would be like imitation, that I'm removing two characters out of it. Else just add the character. At the end, you want to know who won, right? So if the number of such pairs were odd, in that case, player 1 would always have an option of choosing and player 2 won't. So in that case, Latin or the player A would win, else the player 2 would win. Yeah, so this is the correct answer, and we just implemented it using two strings. So the space complexity is order of n and the time complexity is also order of n. Any doubts in this? Everyone had solved this? Okay, cool enough. Let's move to the next question. Okay, not largest y. Okay, give me a second. Okay, largest y only. Cool. Okay, so the problem states that you are given an array A consisting of n non-negative integers. It is guaranteed that A contains at least two distinct elements, right? And then what we have to do is that we have to come up with the element y such that y should be smaller than x. Now x is also a number they would have given to us, and it is a non-negative integer as they've stated. But what we need to do is that we need to make another array out of it. That is the array B, such that each element of B is dependent on A by this formula. So each element or Bi would be equal to Ai or y. So now they're asking it that what is the largest value of y for which you can get the right result. Cool. So the only condition is that in B also, there should at least be two elements that are distinct, right? Or two different elements must be there in B as well. Yeah, over here it says the same. So how would we do this? Let me take you to the iPad. Yeah, that's fine. Okay. So what we can say is that since from A, we are getting B, and how we are getting it? So we are saying Bi is equal to Ai or y. And we'll be doing this for all the I elements. Now, when would this be a problem, or let's say when would when would this particular operation cause such a scenario that all the elements actually become equal? So the condition is that at least two distinct elements should be there in B, right? Should be okay. Let it be in B. So how can we ensure this? The only problem is that let's say we had maybe a few characters like 2, 3, 5, right? So its binary notation is 1 0, its binary notation is 1 1, its binary notation is 1 0 1. Now let's say my m, or sorry, my x, that is the upper limit for the character or the number y I'm choosing. Let's say it was 10. Now in case I choose a y that is 7, now I know that y is not the optimal answer, but let's just assume that for the time being we are picking up a letter 7. Cool. So if I say that my y is 7, then what actually happens is, so this was my a, right? So my b becomes 1 1 1. Over here it will also become 1 1 1, and over here it will also become 1 1 1, because we are technically doing ai or y, right? So how do we avoid these kind of scenarios? So what we can say is that, okay, so I'm going to pick a particular index. So for example, these are the first indices, right? These are the second indices, and these are the third indices. Over here, the remaining quantity is 0. Then I'll say, if this current index, right? If this current index actually has a 0 in y itself, right? It has a 0 in the number y, and what should hold true? So the number, or you can say the number of bits set. So over here we can say for the zeroth index, the number of bits that are actually set are in case of 3 and in case of 5, right? In case of 2, this particular bit is not set, correct? So we'll say if the zeroth index is set more than 0 number of times, so this index, let's call it count, right? So count of I should be greater than 0 and count of I should be less than n, where n is the total number of elements, because if it's set in all the elements, right, then adding it or removing it won't make any difference. However, let's say this particular bit, that is the ith bit, was set in maybe like 3 elements. Cool. So that means in n minus 3 elements, over here I'm assuming that my n is greater than 3, right? So n minus 3 elements, this would be unset. Now if I select a y such that even in y this particular bit is not set, so if this bit is not set, what would happen? If this bit is not set, then in the final answer also for those a of I which belong to this particular set, for all those a of i's, this bit also won't be set, and for all the ai's where this bit was initially set, this bit would remain set, right? So because of that, there would at least be 2 different elements in the entire array. I hope that makes sense. Any doubt so far? Okay, guys, if you have a doubt, just let me know. Cool. Okay, let's come back over here. So yeah, that's what I'm gonna do. Okay, this is some testing. Okay, so firstly, I want to know that at what all bits, how many numbers are set, right? So there are 32 bits in total. Over here, they had mentioned that it's 2 to the power 30. So I could have taken 31, but never mind. It won't hurt actually. Cool. So for all the elements, I'm checking if their 0th bit is set, if their first bit is set, so on and so forth. And I'm storing them in count. I'm doing this because I'll be utilizing it later. So I just wanted to know about the numbers. Now the next thing is that it is possible, right? It's possible that the current element that you or the current number you are having. So, okay, give me a second, where B is the upper limit. I have some problem with nomenclature over here. So I had taken B, you can have taken X, right? Okay. And over here as well, you could have said if nums I XOR or X, right? So what I'm doing over here, I'm trying to check that the maximum permissible value, so maximum value of Y is less than or equal to X, right? So what could be the maximum value of Y? It's obviously equal to X. Now, if I can get a valid answer with X itself, in that case, I already have the best answer possible, and I can I can utilize that. So that's what I'm gonna check. I'm gonna store these values or the AI XOR X in the set nums, right? After that, I'm gonna check if my set nums has more than one element, right? Then B definitely is a valid choice. Cool. If it's not so, then what would happen? In that case, I would be sure that there is some set element in B, right, which I can unset. But over here, we need to understand one more thing about bit manipulation. Okay, cool. So let's say my B was, or not B, but my Y was, or X was. Really sorry for this nomenclature issue, but anyway. Okay, so let's say this was my uh, X, right? Now over here, I see that, okay, this particular bit is set. Now let's say I want to make it unset. So my answer would be 100000, right? And I'm only considering this particular bit right now, but is it the maximum possible value? Definitely not. What I could have actually done is that since I'm making this particular value 0, I could have made all of these values as ones. Now you could say that, okay, is it not going to increase the answer? Definitely not, because all its entire sum would actually be 2 to power n minus 1, right? If this bit is the nth bit or its value is 2 to power n, then the sum of all the bits to its right summed is always equal to 2 to power n minus 1. That's basic bit manipulation, right? So I'm going to say that if I'm going to invert a bit from 1 to 0, then all the bits to its right can be made 1. Now, how can I do that? It's a very easy thing to do. What I can say is that since I already know which bit I'm inverting, right? So I'll say, okay, I'm gonna remove 2 to power n from here, right? But I'm gonna make all the bits to its right equal to 1. Now it's possible that some of the bits were 1 already, right? Still, I'm gonna make all the bits as 1 now. What would happen in that case? In that case, I can say it's 2 to power n or 2 to power n minus 1, where 2 to power n minus 1 is basically this particular value, right? I'll OR this with this value, right? This would imitate the behavior that my nth bit is unset and all the rest bit are now set. I hope this makes sense. So that's what I'm doing over here. If count I is greater than 0 and count I is less than n, so it should not be the scenario that this particular bit is not set in any of the elements of the vector, or it's set in all the elements of this vector. In that case, it's of no use to me, right? And this particular number, right, or the number, okay, I'll just change that so that doesn't causes any confusion. Okay, I think this is fine over here as well. Okay, over here as well. Okay, I'll just check that if this particular bit is set in X, right? So what I'll do is I'll say that my answer is maximum of whatever answer I already have, right? Whatever answer I already have, comma, I'll try to unset this bit. Now, since I already know that this bit is set, I can say XOR this particular bit by 1, right? If I XOR that bit, then the 1 would definitely become 0. Or the right of the sum of all the bits to its right. So these are the ways that you can actually reduce your code by a bit, because in contest it's always better to write precise code. I could have actually used a for loop and I could have checked for all the remaining indices to its right, but it's always easier to code maybe like 5-6 characters rather than 5-6 lines, right? So that's why I use bit manipulations over here. I hope this makes sense to you. Any doubts so far? Let's move ahead. Any doubts in this? Okay, cool. I had muted MD Nihal because there was problem at it isn't. MD Nihal, can you mute your mic? Okay, cool. Cool. Now let's get to the last question for the session, that is minimum operations. Now this definitely is an interesting question. Not because the concept it involves, but because most of the people were able to come up with a solution, but they were missing a crucial edge case or a crucial observation because of which the answer was getting wrong. So I'll try to discuss the problem statement in brief. So problem statement is that we are given two integers n and m, right? And we are also given an array A of size n, right? And then they are saying that all of these elements, all of the elements of the array A would be less than or equal to m, which is another variable that they have already provided us along with n, right? After that, in a single operation, what we can do is we can select any number which definitely needs to be greater than 2 and needs to be smaller than m. Now this is a clever way of saying that you shouldn't make it 1 in just a single go. If over here they had said that okay, x can be equal to 1 as well, then the simple answer would have been that the best possible operation is to use x equal to 1, because anything uh, taken GCD with 1 would actually be 1 itself, right? So that's why they have mentioned that x needs to be greater than or equal to 2 and less than or equal to m. After that, after performing this operation, what would happen is that all the elements in the initial array AI or in the initial array A would now become GCD of AI XOR GCD of AI and X, right? So AI comma X or whatever you want to call it. The task is to make the entire array equal. So the thing is that how do we do it? Now this involves the concept of prime numbers as well as of GCD. So this is the code I have written. Yeah, I know this is a bit long code, but I'll try to explain this to you in as easy fashion as possible. So let's get started with the explanation. Point me out if at any point you feel a bit lost or if I am teaching too fast, so you can let me know. So what we can say is that if we are given any numbers x, okay, y, z, right? Let's just use vw. Okay. So what would happen is all of the numbers by the very property of mathematics can be represented as a multiplication of the prime factors, right? So let's say this is represented as maybe like 2 to power 3 into 3 to power 5 into 5 to power something x and so on and so forth. This can also be represented, this can also be represented, this and this also. Cool. Now what can we do with this? Now we can always try to find what is the maximum element that is present in each of or you can say what is the GCD, right? That is something you can easily find. Cool. So once you're able to find the GCD, or GCD over here basically would mean what is the maximum powers of each individual prime number, right? So let's say over here that it was 2 to power 3, it was 2 to power 2, it was 2 to power maybe 6, 2 to power 8 and 2 to power 200. I know that's a big number, but anyway, like okay, let's just say 2 to power 10. Cool. Now when you'll be taking GCD, so you'll be considering 2. For 2 you'll say that okay, for 2 you'll be having the number 2 to power what's the minimum value you're having? 3, 2, 6, 8 and 10. So the minimum is definitely 2, right? So this is the number. Now for 3 you are having 3 to power 5 over here. Let's say it was 3 to power 2. Over here there was no power of 3, so basically 3 to power 0. Over here it was 3 to power 1. Over here that was, let's say, 3 to power 3. Cool. Now what is the minimum power of 3 you are having? That's 3 to power 0. So on and so forth for all the numbers you can do. Now I did it via complex procedure, but what you can actually do is you can simply take a GCD of all the numbers, right? For all nums in nums. Okay, in nums. Take GCD. Now what you can do is after this, just say what would happen if all the numbers are already equal. So initially also you could have checked it. If all your numbers are equal, in that case you don't need any sort of operation, right? In that so because the goal you wanted to achieve at the end was that all the numbers should become equal. If they're initially all the numbers are equal, then you need not do anything. Cool. But let's say now all the numbers are not equal, then what we can do? So we can say that okay, if we are able to come up with a number that is this, right? We are able to come up with a GCD with G that is not equal to 1. In that case, I'll say that okay, I just need a single operation, right? Now why can we use GCD not equal to 1? Because what would happen is that they have said that the number you are gonna use as okay GCD AI comma X, right? So the number X that you're gonna use should be greater than or equal to 2. So 1 is not something we can use. If it's greater than or equal to 2, good enough. We already got our answer. We need a single operation. And in that single operation, we want to do GCD of AI comma X for all I, right? Less than or equal to N. However, if GCD becomes 1, in that case, what we'll do? So it's possible. Now in this particular scenario, most of the people made mistake. So what happens in this scenario is that let's say you had a few numbers that is like 6 and 7. Now people just wrote that the answer would always be that we'll be using two numbers that are 2 and 3. The problem is, let's say the numbers are 6 and 7, right? With firstly we'll take a GCD with 2. Okay, that would actually yeah, firstly we'll take a GCD with 2. The answer would be 1. Sorry, GCD with 2 would be 2, right? And GCD of 7 with 2 would be 1 itself, right? And then you'll take the GCD with 3. So 2 comma 3 taken GCD is 1. 1 comma 3 taken GCD is also 1. So definitely you reach to the right answer. So what's the problem? The problem is it's not the optimal answer. So even in a single operation, you could have made it 1 and 1 by selecting a number 5. Cool. So this is what you need to know. Now how would we come up with the number 5? What we can do is we can initially store all the number of prime factors, right? Or all the number of primes which are less than or equal to 10 to the power 6. This is the order of 10 to the power 6 operation, right? So definitely you cannot do for all the test cases, not for all the test cases, right? But rather what you could have done is you could have said that, okay, I'm just going to store it initially itself, not inside for each of the test cases. I'm not going to perform this, but globally before even starting this execution for this for these test cases, I'm going to compute the prime numbers. And then you're going to say for all the prime numbers, check if there's any prime number which is not a factor, right? Which is not a factor of any which is not a factor of any of these numbers. If there's such a prime number, right? So over here, the prime numbers that are actually smaller than 7 were 2, 3, 5, right? So you could have selected 5 itself over here because 2 and 3 were actually a factor of 6, correct? The only prime number which was not a factor of 6 and like was smaller than m, let's say m was 7 over here in the initial case we said, was actually 5. Cool, I hope this makes sense. Now what I'll try to do is that initially I had coded up a pretty complicated solution. I don't want you guys to go over that because it's actually complicated and no point in discussing that. But right now we'll try to code it up and we'll try to code a much simpler solution. Is there any doubt in the explanation? Everything was fine? Shall we start coding it up?
Yes, sir.
Okay, cool, bro. Cool, so let's code it up. Let's bring this to our editor. Fine, it's over here. So we are having two elements that are n and m, right? We'll take the inputs after that, and then I'll say that I want to the GCD initially be v0. Okay, and let's just check if all the elements are same. How can we check them? An easy way would be to sort all the elements. There are multiple ways of doing it, but anyway, I'll just keep it short, right? If my v0 is equal to v back or vn minus 1, in that case all the elements are equal and I can say 0, right? And I can return right over here. Else I'll traverse across the entire array and I'll update my GCD. So g is equal to underscore underscore GCD of g comma I. Cool. Now what can I do? Now if my g is equal to 1, right? So that's a problem. If my g is equal to 1, then I cannot say that I'm gonna perform a GCD with 1, right? Then that becomes a problem. Else I can just say that the answer is 1. I need one operation, and in that particular operation I just want you to take a GCD with g itself, right? That's fine. But what if my answer is 1? Over here we'll start building our prime numbers. Now I already have the code written for that, so I'll not be writing it again. So I have that stored in the snippet called prime snip. I'll just enter over here. So yeah, here's the code. So the size etc has already been set, and I'll just build this sieve even before starting the execution for all the test cases. So I'll say build sieve, and with that I'll have my prime number stored, right? So over here I can say for all the primes. Okay, for all the primes in P, or all the all the primes which I have, right? Okay, and C equal to 0. Okay, give me a second. I'll have to check for all the elements. Okay, elements in V, like if L mod P equal to 0, that would mean that my element is able to divide it, right? That's a problem for me. So if it's able to divide it, then I cannot use this particular prime number. So I'll say bool okay equal to true initially, but if this happens, then I'll have to say that okay, it's okay is equal to false. Cool, and I'll break, because even if it found a single element that is divisible, then it's enough for me to say that I cannot proceed with this number. But if it's true, so if my okay, right, then I already got an answer. So the answer is I'll just need one operation, right? And in the single operation, I can use this prime number P, because P does not divide or does not have is not divisible by any of the numbers that I have, right? So in that case, that is valid. Okay, I'll have to return over here. What would happen is that there are scenarios in which this would keep continuing. So what would I do in those cases? If this keeps continuing, then at the very end, I'll never hit this okay statement, right? And I'll say that one of the answer I definitely know would exist is 2. Two number of operation, one of the elements is 2 and the other elements is 3. Cool. Any more modifications we can do over here? Yeah, we can do one more modification. We can check if the current prime is already greater than m. That m is actually the limit of the number you can use. In that case, you can break it. I hope this makes sense. Let's try it out. It's the first time I'm coding this solution up actually, so there could be some problems. Seems to work. Let's paste it over here. Okay, anyway, it's gonna take time now in minimum operations, but yeah, that's the logic. So okay, let's just wait for it. Let's see if there's a problem or it passed. Cool, so it passes, and you can see the code was actually pretty small. In case you have these prime snippets already written, then it's small, then it's easy. Even if you don't have these, then also it was easy, because like there was only 5-6 lines of code you would have written on yourself, right? So it was anyway easy to code it up. Cool, I hope you understand this solution as well. Any doubts in this? All clear? Okay, Sharon is typing something. Awesome, always. Cool, bro. Thanks a lot. Harsh, you got the solution. Anyway, I'm gonna close the recording now. I'll take your doubts in.